Kind attention, please. We are about to start our workshop in 5 minutes. I request to all our participant friends to kindly mute yourself throughout the event as it may cause disruption to our speaker's speech.
So good morning, good evening, and good afternoon. I think we have got people from all three different places. We got a morning, afternoon, and evening also. So good morning, good evening, and good afternoon to all these attendees and esteemed invited speakers, and my colleagues from IIT and IMechE members. It's the first workshop that we are having, Indo-UK Japan workshop on climate resilience. Let me first introduce myself. I'm Milind Atrey. I'm a professor of mechanical engineering department at IIT Bombay, and also the chair of the IMechE, the process division in India, and also I'm the Dean R&D currently at IIT Bombay. So on behalf of this organizing team, along with my other colleague from IMechE, Dr. Tim Fox, who is the chair of IMechE Climate Change Adaptations Working Group in UK and the past chair of the process division IMechE, and Mr. Hibina Masaki, who is IMechE Japan committee chair and also the project manager Hydropower Erics Corporation Japan, along with the convenership of my PD secretary, process division secretary, Mr. Sunil Panchabai, who is the secretary of process division IMechE here in India, and Professor Parthasarathy, who is a professor of the Interdisciplinary program on climate studies here at IIT Bombay. I welcome all of you for this first Indo-UK Japan workshop on climate resilience. I think we had planned this workshop to happen somewhere in the last year, but because of the pandemic, we had to postpone this. But I'm very glad that this is happening at the end. And today, in spite of the weekend, we have had several registrations, and I'm sure we'll have fantastic response time to come. This idea of having a workshop actually was germinated when Dr. Tim Fox and myself visited Japan for a similar workshop, and we seriously felt that there's a need for a larger audience, larger actions, serious consideration, and implementation for such an important topic of climate resilience. And there's a lot in store for you in this workshop. We have got 3 plenary talks followed by 3 parallel sessions on different themes. As you know, this is an online event, and I'm sure there could be some problems due to internet issues or audio-video problems, but I'm sure all of us will be patient enough and would tolerate some inconvenience also. The process division in India, the process division group of IMechE in India is pretty active. We organize such workshops and webinars. Last one which we had was carbon capture, etc. almost once in 2 or 3 months. And we have a very active IMechE body here who are having programs in different zones and different places, including Delhi, Bengaluru, Kolkata, etc. I must thank Dr. Parthasarathy, who is a professor, my colleague here at IIT Bombay, to take the responsibility of organizing this as a co-convener, and also Dr. Subimal Ghosh, who is the current head of the IDP of Climate Studies at IIT Bombay. I would now request Dr. Tim Fox to give a brief background of this workshop and his thoughts about it. Tim, sorry.
Thank you very much, Milind. I'm very grateful for your introduction. I'd like to share my slides if possible. Is it possible to give me the control to share my screen? Devasmita?
Yes, sir.
Okay, that's good. I have control. Thank you.
Yes, thank you.
Okay.
It is there.
I'm still here, and I'm just starting the slideshow. Okay, can everybody see that?
Yeah.
Okay, well, thank you very much, Milind, for that kind introduction, and it's a great pleasure that we are indeed presenting this event that we had intended to do physically together in India, but this is a great way of adapting to the current global pandemic situation, and I appreciate you and your team putting this together. My role initially is going to be to provide you with an overview, a sort of scene setter, an introduction to the topic of adapting to climate change. And then the plenary speakers will make their responses in their presentations, and then we will move into the workshops where I'll be talking about sea level rise specifically. So let me begin by setting the overall global scene to this rise. So just to provide the context, I'm not going to go into all the detail in some of these slides. They will be available on the internet in the recording later, so you'll be able to review some of the statistics and facts. But most of us on the call are probably very familiar with the result, the publication recently of the IPCC's physical science basis section of their assessment report 6, and they were very clear that in terms of the current climate, it's unequivocal that the humans have been influencing warming the atmosphere, the ocean and land, and that it's certainly been getting warmer in the past few decades. And from the perspective of setting the scene in this workshop, it's absolutely important to recognize that globally average precipitation over land has increased since the 1950s. And it's not only has it increased on average, it has increased in frequency and intensity. And we'll be addressing that in one of the parallel sessions. Also, hot extremes have become more frequent and intense across most land regions since the 1950s. And this leads to a demand for cooling, which we'll be addressing in one of the parallel sessions. And as I've mentioned earlier, the land-based glaciers and ice sheets are retreating, and they are now the dominant contributor to sea level rise. And as we go forward, the IPCC's projections, all of their projections that they provided in the recent report, show that we will likely exceed 1.5 degrees C of global warming at some point within the next few decades. In the case of the lowest emissions scenario, assuming we're successful at creating a net zero future, the temperature will decrease towards the end of the century and return to a level below 1.5 degrees C. But in all other scenarios, it exceeds it, and in some cases quite excessively. So there is an inevitability that during the next few decades, we will see an increase in the frequency and intensity of hot extremes, heavy precipitation, and a continued increase in sea level rise, which are the topics of this event today. And many of these changes will quite clearly be irreversible for centuries to come, and indeed millennia to come, in particular if we're looking at sea level rise and the impacts on the oceans. So IMechE has a tradition with a long established over a 15-year to 20-year time frame of addressing this inevitability in needing to adapt to climate. And we do this through our learned society activities. And some of the reports that we've produced over the years are shown in the slide here. And we engage widely with government, civil society, and the public around this topic. So, as I said, we need to respond to increased heat extremes. And this event today is looking at workplace-related issue as well as residency-related issues. And typically as engineers, we think of providing mechanically based air conditioning. And this is going to be a real challenge going forward. And we could see something like a 33 times increase in the demand for energy for air conditioning as we move through the century. So clearly that's an unsustainable and untenable future, and we need to do something about that. And there are a number of areas we need to address, which I've pointed out on the slide, including emissions from the leakage of high global warming potential refrigerants, the use of fossil fuel-based power to run the air conditioners around the world, and the sustainability of manufacturing processes, etc. And clearly that will be addressed in the parallel session with some degree of detail. Of course, from a process engineering point of view, this also causes us problems with our air cooling systems and our liquid and water-based heat exchange systems, and indeed overheating of plant and feedstock and product itself. So we need to adapt to this in the coming decades, and we need to do that, of course, in the context of net zero solutions. On the issue of sea level rise, I'll be talking about this in great detail in the sea level rise session, but we need to be cognizant that there could be significant levels of sea level rise during the course of the century, potentially up to 2 meters by the end of the century, and possibly up to 5 meters by 2150. And of course, all of that is within the lifetime of engineered infrastructure and refurbished infrastructure, which can be around for decades into the future, 50 to 100 years or possibly more. So this warrants a new perspective by us as engineers. So how can we design and operate in such an uncertain world? Well, that's partly the topic of today's event, and we'll be exploring that and discussing that in the workshop. But of course, as engineers, we typically work within the context of design standards, design codes, and building regulations. And there is much work going on about that, and we'll be hearing from John Dora in a moment in the first plenary talk about work that's going on here in the UK and across Europe on addressing climate change adaptation within standards and design codes. But there is still an enormous amount of work to be done to deal with the uncertainty in the future of those climate changes and the sea level rises that will result from the melting of the land-based ice sheets and glaciers. And of course, the outcome we're looking for as engineers is we need an adaptive, ready, future-proofed approach to new builds and refurbishments. And John will be discussing that in much more detail. So from the IMechE, one of my concluding remarks as to the priorities for engineering in building long-term adaptation capacity. Well, traditional design methods are no longer going to apply, and we're building infrastructure and the built environment today that needs to be addressed in a different way from a design point of view. So we need to develop alternative approaches, technologies, guidance, methodologies, and tools that are not based on historical data, but based on future climate. And we need to ensure that our adaptation solutions are, of course, sustainable, flexible, that they're resilient and adaptive ready, and they're appropriate to local knowledge and skills. And most importantly, they need to be net zero solutions. We don't want to increase the emissions problem through our solutions. And we need to recognize that we have to do this in a much broader collaboration with other actors and players in society who come at this from a socio-economic or political point of view that forms the context for our work. We cannot work as engineers in silos. And there is a huge need across the profession to deliver knowledge, transfer, training, and skills to enable us to be fit for purpose for adapting to the climate change challenges of the 21st century. And indeed, that is what the inspiration of this workshop is and will be in future events going forward. Thank you very much for your attention.
Yeah, thank you, Tim. Thank you very much for setting the momentum for this workshop. May I now invite Professor Subimal Ghosh, who is the head of the IDP of Climate Studies here at IIT Bombay.
Thank you, Professor Atrey. Good morning, good afternoon, and good evening to all the attendees who are participating in this workshop or who are attending the workshop. Let me introduce myself. I am Subimal Ghosh. I am heading the Interdisciplinary Program in Climate Studies at IIT Bombay. And I am also associated with Department of Civil Engineering in IIT Bombay. And my research interest includes climate extremes, hydrometeorology or hydroclimatology, climate change impact assessment, specifically focusing on the water resources. So let me introduce a little bit about our interdisciplinary program in climate studies. First of all, I would like to say that our climate studies is a PhD program. It's a doctoral program. It's a first of its kind. So in India, it was the first doctoral program focusing on climate change in India. And we, in our IDP climate studies, we work on interdisciplinary projects or interdisciplinary areas, focusing on climate science, climate adaptation, and climate mitigation, all the three areas. We have around 32 faculty members from 11 different departments. So 11 to 12 different departments that include civil engineering, humanities, environmental science and engineering, mechanical engineering, Center for Technology Development for Rural Areas, Energy Science, and so on. So faculty members from 11 or 12 different departments, they come under the umbrella of climate studies and they work together. And we make sure that each of the PhD student is guided by faculty members of two different departments, so that each and every work which is coming out of climate studies has a proper interdisciplinary figure. As Professor Fox was mentioning about the IPCC report, and very recently United Nations Intergovernmental Panel on Climate Change has come up with a report, which is the Working Group 1 report, and that clearly said that there is an urgency, there is a climate urgency, and we have to act now. We are now, so in fact the media also consider it as a sort of a red alert kind of thing for the humanity. And for this purpose, the important part is now any kind of scientific development or technological development cannot really avoid climate. Climate needs to be a part of any kind of engineering design or any kind of scientific development, and that's very important. And our interdisciplinary program in climate studies is actually focusing on this area. So what we are doing, we are actually involving faculty members and students from different departments, so that we can introduce climate into different design and different scientific developments in different sectors, starting with health, water resources, food, agriculture, environment, and so on, and energy, and so on and so forth. Over the last 8 years, the climate studies has actually made significant research contributions in terms of development of new research, new technology, development of new research products, new data sets, and different kind of publications. In fact, I am very happy to say that over the last 8 years, we have published more than 150 journal publications that includes some of the high impact venues like Nature Climate Change, Nature Communications, Nature Sustainability, Science Advances, and so on. And I'm really proud of all of my colleagues who are actually contributing quite significantly and making the work related to climate change really prominent nationally and internationally. So we work mostly in the area of, as I mentioned, climate science, which focused on Indian monsoon, the aerosol climate interactions, the air pollution, then coming to water resources, understanding climate extremes like floods and droughts, and how are they impacting agricultural activities, how are they affecting human health, and finally on how can we improve the climate services. So we do not really just focus on climate science, but we focus on climate services and solutions. Let's say if a weather forecast comes, how to really make them usable by the farmers, by different users. How can we come up with a better flood evacuation planning? How can we come up with a flood forecasting system? How can we improve the urban resilience? So, and also on the mitigation, like how can we really improve different technologies? How can we come up with different green technologies, or how can we plan for proper afforestation that can help in carbon sequestration or understanding how vegetation is actually interacting in terms of carbon cycles. So we are actually covering all broad area of climate science and covering each and every sector. And this is the way we work. And we find that this is an excellent opportunity for us to collaborate, to interact with the experts from different areas, different countries, and I'm very sure that this workshop will help us to come up with newer scientific ideas, so that we can really contribute to humanity. Thank you very much. I once again welcome you all on behalf of Climate Studies IIT Bombay. Thank you.
Thank you very much, Subimal. That was a fantastic introduction to the department, and I know how much work is happening in this IDP center. May I now invite Professor Parthasarathy, who is the convener of this program, to take this ahead from here and get started with the plenary talk. Professor Parthasarathy?
Yeah, thank you very much. I hope I'm clearly audible now.
You are clearly audible now. Good.
All right. Thank you so much. Thank you, Professor Ghosh, for that excellent introduction to the work of the IDP in climate studies, and Dr. Tim Fox for a very clear and concise overview, which helps us to advance the agendas behind this workshop. And Professor Atrey, not just for the introduction, but also for pushing us and working with us very closely to organize this workshop. I'll just spend a minute on talking about the origins of this workshop. So Dr. Tim Fox had visited us in IIT Bombay about 3 years ago, and several of us from the IDP in Climate Studies here at IIT Bombay met him and discussed issues related to coastal resilience, especially resilience of coastal infrastructure. And as we've been seeing for the last few years, as scientists have also been saying, the hazards and the risks from climate change are coming upon us much faster than anticipated. And the Western Indian Ocean is no exception to this. And we have seen this year and the previous year, there was a cyclone which struck the western part of India, the western coast, and Mumbai was affected as well. And scientists are explaining that partly due to climate change, sea level rise, and increase in sea surface temperature, the frequency and intensity of cyclones and storm surge is going to increase on the west coast of India, whereas the east coast was more affected earlier. And we've seen how much of the infrastructure in the coastal areas, not just power, transport, water, and so on, but even the small scale infrastructure which dots the Indian coastal villages, like small ports used by for fishing, and other infrastructure which are not very robust and not prepared for climate change, they have been quite severely affected. So this workshop is very timely, and I'm glad that it's finally got off, and we're able to attract a very large number of motivated and interested participants. We started thinking about this in 2019, but because of the pandemic, we had to postpone it as all of us got affected by too many things. And then finally, we decided to go ahead with it online. And Professor Milind, Dr. Tim Fox, Mr. Sunil Panchbai, and Ebina-san from Japan, along with some of our students, staff, and postdocs have worked quite hard to get this going. So I'm happy that finally we are able to organize this. Among our objectives, there was also one key goal that we were looking at, and this was to enhance great collaboration between government, academia, and the private sector, especially on the 3 themes identified for this workshop, which is cooling, industrial and residential cooling, coastal floods, and sea level rise. And we're very happy that almost everyone whom we approached to give talks on this have agreed, and all of them are leading figures working in these areas, either in academia or in industry or in government also. And we hope to have a very interesting session, and this is only the beginning, and we hope to take this forward and have a similar event every year so that we can form a network among academia, government, and industry across India, Japan, and UK, and maybe also extending to other countries later. So the partnership with the IMechE is very useful and valuable because they already have a very significant network with industry and government and academia, and we hope to build on that and get several of our faculty and students from IIT Bombay and the IDP in Climate Studies into these collaborations. And one key aspect of this workshop and our motivation in forming this network is also to focus more on standards. And several of the speakers have actually worked on different kinds of standards for infrastructure, for refrigeration, for cooling, and the different themes that we're going to discuss today. And while we've not been very successful in working with the Government of India's scientists working on standards, we hope that this will be a beginning, and the collaboration between different sectors and different countries will help us advance research as well as design and implementation in areas related to standards for coping and adapting to climate change. With this brief introduction, I'd like to start this plenary session. So we have three speakers today, and I'll introduce them one by one, and then I'll introduce each speaker, and then they can speak for about 15 minutes. Please stick to the time as far as possible, and so that we have time for a little bit of discussion, and we can always have more discussion during the breakout sessions and in the final session as well. So we have Professor John Dora, who's director at Climate Sense and at John Dora Consulting. He's also a visiting professor at the University of Surrey. We have Yuzaburo Yajima-san, who's manager corporate social responsibility and global environment center at Daikin Industries in Japan. He's also been associated for many years with the Japan Refrigeration and Air Conditioner Industries Association, where he's been a key contributor to the A2L Refrigerant Committee on risk assessments. And then we have Professor P.P. Majumdar from the Professor Department of Civil Engineering and chair of the Interdisciplinary Center for Water Research at ISC Bangalore. And he's not just been a very significant figure in advancing research on climate change, especially focusing on floods, but he's been a key institution builder, and the students, the PhD students he has produced are all over India and abroad, and many of them are here in the IDP in climate studies. So he's played a very significant role in advancing education and training and capacity building in topics related to climate change. So we're very glad to have all three of you. So I'd first like to request Professor Dr. John Dora to begin his talk. As I introduce him, maybe you can set up your slide. So Professor John Dora is a visiting professor at the University of Surrey. He's a recognized international expert on climate change adaptation standards and infrastructure asset management. He has over 40 years experience in infrastructure, including in areas related to flood, risk management, and asset management of railway structures. So these are very important areas for us here in India as well. He's been the initiator and technical advisor to a very large project on rail safety standards in the UK. And about 10 years ago, he co-founded and is the chair of the UK's Infrastructure Operators Adaptation Forum. So he's known as a researcher and consultant in the field of infrastructure resilience and engineering, and he launched the firm Climate Sense in 2019, of which he is the current director. Professor John Dora, the floor is yours.
Thank you very much, Professor. Can everybody hear me all right and see my slides?
Yes, yes, absolutely.
Thank you. Good afternoon, good evening, good morning, everybody. I'm honoured to be part of this alongside such an august group of people, and hope to continue being part of it. It's a great initiative, and having looked at climate resilience issues over the past 20 years, it's really encouraging to hear so many courses and so much training going on under the banner of climate issues, because 20 years ago, there were very few of us active in this area. This is really encouraging. But I want to get into this short presentation about addressing climate challenges using standards. And the case for using a standard, and there's a picture here of ISO 14090, which I'll talk about. Standards set out an agreed way of doing things and are drafted by experts. So one of the phrases I hate hearing and dislike is something is best practice, because I always ask, how can you judge that? But international standards are best practice because they've been written by experts, acknowledged experts in their field, and standards provide a recognized benchmark across communities, across societies, across countries, and they're used to provide consistent results. ISO 14090 is what I'll talk about, which is adaptation to climate change, and it supports other mature standards that have been around for a long time, such as ISO 14001 environmental management and 55000, which is about asset management. And I'll talk about how it links in with 14001 later on for a bit. But I want first of all to draw your attention to ISO 14090. This was published in 2019, and it's the first of a series of adaptation ISO standards. And one of the things I do say to people when I talk about adaptation risk, and in my work as a consultant over the years, I've had many organizations come to me and my colleagues and ask if we can carry out a risk assessment to look at climate risks. Well, adaptation isn't just about assessing climate risks. That's part of it. Climate impacts, climate vulnerabilities is part of it. But you need to wrap an organization around dealing with those risks and impacts, because they will change over time as capacity to understand the issues builds and the climate changes. But 14,090 has an interesting section in it that I'll touch on in a minute, but it looks at initially the governance arrangements of an organization, the leadership and awareness throughout the organization, and it makes that leadership think about the life cycle of their products or their activities or their services. Products, activities, and services is an ISO, an International Standards Organization term. It looks at the capability in the organization, the knowledge and resources, human resources, financial resources, to develop and embed and sustain an adaptation plan. And then we come down to the bit about assessing impacts, the risks, vulnerabilities, and thresholds. And it also, very importantly, looks at cross-cutting or systemic matters. Now, me working in the field of infrastructure, I appreciate that a transport system, such as a railway network, needs energy and road transport to make it work. So there are interconnections across different systems that need to be addressed. And this standard helps organizations to look at other factors outside of the narrow set of factors they might think of themselves. Now, here is a link on this presentation. When you get a copy of it, there's a link that you can click on to for this ISO white paper that shows how we can use 14,090 to support 14,001. And remember, ISO 14,001 is the Environmental Management Systems Standard, and it's the second biggest selling standard globally. So ISO 14,090 is applicable to any organization. It's a high-level document that sets out a framework for adaptation, and you can use it at any stage of adaptation. Now, I'm giving some talks in early October at the Adaptation Futures Conference that's being run from New Delhi, and I'm giving a presentation similar to this one, but I'm also looking at some case studies of people who have been using 14,090, and it includes organizations not wishing to have accreditation to the standard, but organizations who wish to check how well they're going with adaptation against international best practice. And I can sort of exemplify transport organizations, a regulator for transport, a health service, and the UK's National Trust, which is the fourth largest landowner in the UK, looking at how well they're doing against 14,090. 14,090 can be used at any stage. You can use it to come up with tailored solutions for your organization. It's not something that you can do X, Y, and Z. You've got to think about things before you actually produce an adaptation plan. And you can carry out an analysis or use it at any stage. You might be an organization, a local authority, a transport operator, a cricket club that has an adaptation plan. But you might be starting out on your very first engagement with the adaptation issue. And you can use this standard at any one of those stages. But importantly, it aims to embed adaptation as a normal activity, not a special project, but business as usual. And importantly, it helps to build capacity. I heard the adaptive capacity phrase earlier on, which is great. Adaptive capacity is enshrined in the Paris Agreement Article 7 on adaptation. And of course, it supports the UN Sustainable Development Goals as well. I've just made a link in there to some training courses that my company is operating, if anybody is interested in that sort of thing. I'll mention quickly now the International Standards Organization standards strategy. And we have this diagram here, which if I get my pointer out, you can see pre-planning, assessment, planning, implementation, monitoring, and evaluation. These are all stages or clauses in ISO 14090. And the strategy that we have in ISO is to seek volunteers, and if anybody wants to engage in ISO adaptation standards drafting, please do speak to the Bureau of Indian Standards or Japanese standards, because all these good organizations help us with experts to produce standards. The strategy is to take these clauses and develop more detailed standards that give guidance for people that need that guidance. And indeed, ISO 14091, which is on impact, risk and vulnerability, has been published, and 1492, which is on planning for adaptation in local authorities, has been published. And another one that has been published that isn't an ISO yet is the British standard 8631, which deals with adaptation pathways, which is a great technique for dealing with uncertainty. Now, I can mention that this strategy is under my guidance because I chair the task group that looks at strategy for ISO for adaptation. I'm aided by Tim Fox as well, who's on this conference. So well done, Tim, for helping out with this. There's more to come though, because 1490 provides a framework, we're developing the strategy, and we might have horizontal, which are not specific to any sector standards coming along, or you could have vertical specific to a sector standards. An illustration there was that the non-specific would be 14,092 is specific to local authorities, but 14,091 is general for any organization. And like I said, we're looking at adopting 8631, the British standard on using adaptation pathways. In Europe, we're also looking at this European Commission mandate 526, work managed by the Netherlands standards body to modify infrastructure standards for a resilient future. And this illustration here is showing that, we've got COVID, a recession, and climate change we think is much bigger coming along behind COVID. And this is just a picture showing how this mandate has influence on many parts. You will see here that I am involved in this group here working on some work to look at infrastructure standards, and I'm influencing Technical Committee 250, which is the one that drafts the structural Eurocodes, which are used the world over for the safety of built infrastructure. But there are many director generates in the European Commission who are involved in all this, including Copernicus, which provides climate data through the Climate Data Store in the Climate Adapt European Environment Agency interface. This mandate is asking us to produce guidance for standards users so as they can source the right climate data for the future. I'll talk quickly about BS 8631, which is about using adaptation pathways with decision making. Interestingly, it considers a lot of the issues that 14,090 talk about, but mainly it's about understanding uncertainties and opportunities and planning for a future range of climate scenarios. What it does is it uses a number of examples to show people how it can be used, with a case study based on, among other things, the Thames Estuary 2100 plan, which includes long-term thoughts about London's tidal defences and the Thames Barrier. If you consider this barrier complex, which was commissioned in the early 1980s with a 50-year life, by the end of this century, it will need to be about a metre higher, and the TE 2100 plan looks at different options for the future, including raising embankments and a new barrier. The pathways approach allows you to consider these options for different scenarios in the future, and also recommends that you choose a scenario and an option, particularly the option, so that the option that you use for your intervention does not get in the way of future options. I'm thinking of London here. I'm thinking 200, 300 years ahead into the future, of course. We need to think long-term with infrastructure. So my conclusion is that we can use standards to help addressing climate change impacts because they are an agreed way of using best practice, international best practice, but we can also use standards like 14,001 or 55,000 to encourage our directors, our businesses, our organizations to use 14,090. And there's more to come from ISO and CEN and other national standards bodies for future proofing infrastructure over time. And one major point I would like to make is that the standards give you the technical and management criteria. Many people come to me and say, oh, but it's too expensive. Now, if it's too expensive in 2021 to incorporate the future climate in infrastructure that might be around for 50, 100 or more years, it'll be many, many more times expensive as the climate is changing. There's an urgency here. We need to use different criteria for our design and maintenance and operation of our infrastructure, and we need to do that now. And people like myself as engineers have influence. We can persuade people to change standards now and wait for a couple of years for the structural Eurocodes and other things to change. Thank you very much.
Yes, thank you, Professor Dora. And that was, I think, many of us are not from this background of looking at climate change challenges from the perspective of standards. And so I think that was a very useful introduction to thinking about it in this way. And thanks also for introducing us to the different ways in which the existing standards, protocols, ISO and others have large applicability. And this is something that I personally also was not aware of. The wide applicability, I think, makes it very useful for addressing different kinds of climate change risks in different sectors. And I think that was a very useful start to the discussion and the overall theme of this workshop. Thanks also for finishing well within time. We'll take a few questions and comments at the end, and then we'll have a short break before we move to the next session. So I now request the next speaker, Yajima-san, to give his presentation. Yajima-san is the Manager, Corporate Social Responsibility and the Global Environment Center at Daikin Industries. I think he's been with Daikin for over 50 years. He's got enormous years of experience on alternative refrigerant research, as well as significant work on risk assessment for new refrigerants. Yajima-san has also been associated for many, many years with the Japan Refrigeration and Air Conditioner Industries Association, where he's also significantly contributed to risk assessment of A2L refrigerants. He has, to his credit, a large number of inventions and patents in this area, and especially on technological solutions related to energy conservation and reduction of emissions in the refrigerant and cooling sector. Yajima-san can present.
Thank you for kind introduction from
Your voice is quite feeble. Can you speak up a little bit more?
Oh, can you hear me?
No, still quite low.
Oh, okay,
It's better now.
okay. First of all, let me introduce my company in short words. Daikin just only one manufacturer around the world producing both of air conditioners and refrigerants. Today, I would like to talk about Daikin's refrigerant policy for sustainable development. This is contents, history of refrigerant and air conditioners, and big issues of refrigerant. Our big challenges and industry summary. This slide shows the innovations of cooling technology and the change of refrigerant. I'll explain this history in the United States, that it's similar Japan also. The larger centrifugal chiller, firstly introduced into a movie theater, Broadway, gave all audience cooling air. And this technology had grown the movie industries like Hollywood. Cooling device on a moving truck gave us revolutions of food industries. Fresh vegetables and fruits cooled in this truck can be supplied to everywhere in this country. Non-toxic and non-flammable fluorine refrigerant R12 and R22 had been driving forces for these innovations. Issue of refrigerant. As you know well, here two environmental issues of fluorine refrigerants. The first issue was the ozone depletion by fluorine refrigerant, including fluorine atom that destroy ozone layer in stratosphere. This issue had already been solved by HFC refrigerant, not including chlorine atom. The second issue is the global warming by fluorine refrigerant having the bond of carbon and fluorine that radiate flared ray back to the earth. Fluorine refrigerant are very stable, and consequently they have very long lifetime in atmosphere. That this good property for human being poses to global environment problem. Air conditioner market will grow more further, especially in developing countries. High GWP HFC refrigerant continues to be used. CO2 emissions will also rapidly increase. This is not sustainable growth. Kigali Agreement in Montreal Protocol introduced the upstream regulation of HFC production and consumption. In developed countries, from 2019, the total amount regulation started. 2036, it must be decreased to 15% of baseline. Our challenges. We have trade-off between global warming potential, WP, and flammability. Burning velocity, good index for flammability. For example, 290, that is propane, has nearly zero GWP, good refrigerant. But propane is highly flammable gas. You can see that combustion of R290 like an explosion, very fast propagation of flame. On the other hand, R14A, non-flammable, that has high GWP value, about 2000 relative with CO2. R32 shows lower flammability and lower GWP values, 675. It is a third of R14A. You can see the very slow combustion of R32. How to select lower GWP refrigerant? GWP and flammability are in a trade-off relationship. We need to evaluate the risk of this flammability, and we need to supply safe products to users. What is safety? This figure, vertical axis, shows probability of harm. Horizontal axis shows severity of harm. Risk is defined as a product of severity of harm and probability of harm. Red zone shows an acceptable risk for us, too dangerous, and blue zone, acceptable risk. Safety means freedom from risk, which is unacceptable for us. This slide shows risk assessment result carried by Japanese manufacturers industry for each type of products. Result shows that residential and light commercial products with R32 can be used safely in our market even without special safety measures. Our policy is diversity and sooner the better. We don't have one almighty refrigerant appropriate to all products. We selected each refrigerant for each product. Daikin has supplied approximately 23 million units of R32 residential air conditioner or heat pump more than 90 countries and regions. Indian market is a very hopeful market for us. and R32 products exist mainly in Indian market. And let me go back the principle of refrigerant molecule by using periodic table. Black zone shows metal, aluminum, and gray zone shows semiconductors. Orange zone, inert gases. We cannot use these elements as a component of refrigerant molecule. We can use only hydrogen, fluorine, carbon, nitrogen, oxygen for refrigerant. This fact gives us some selection of future refrigerant. Firstly, the very simple selection, no carbon-fluorine bond in refrigerant molecules, that is hydrocarbon. It brings us near zero GWP, that brings us also high risks due to high flammability. Another big challenge for us to introduce double bond into a molecular structure. This double bond is very unstable, and the life in atmosphere of these molecules is just only 1 day. Then GWP can be very low. The third challenge is to use lower GWP and lower flammable refrigerant R32 and to decrease emission into the atmosphere of the gas by recovery and reuse of refrigerant R32. Daikin selects the third challenge, and we will continue all efforts for future sustainable development. Summary. I'd like to two item and go to the last point. Low or zero GWP refrigerant have some challenging issues. That's why we'll continue our effort to 2050 carbon neutral. Thank you very much.
Thank you, Yejima-san. It is great to get an industry perspective on this after hearing Professor John Dora, who straddles the fields of consulting, research, advocacy, and academia. And we have a lot of student participants here, and therefore I think the points that you made about focusing on basic science, starting with elements and molecular structures, and understanding that there are challenges to older technologies, but also to new alternatives. I think this is a very important lesson because we tend to get too much excited by the need to address climate change risks, but we forget that the science is quite complex as well, and we need to start with the fundamentals. And I was also glad that you began with focusing on how cooling and refrigerants are not just about comfort, they are significantly related to social development in so many different ways, especially food. And I think that's why it remains such a big challenge to work in this area. Thank you very much. I would now like to request Professor P.P. Mujumdar from the Indian Institute of Science to make his presentation. Professor Mujumdar is Professor of the Civil Engineering and Chair of the Interdisciplinary Center for Water Research at IISc Bangalore. He is also the KSIDC Chair Professor earlier, and he's an associate faculty in the Center for Earth Sciences at ISC Bangalore. He's specialized in water resources with a focus on climate change impacts on hydrology and water resources. Very important in terms of climate change research, is contributed significantly to statistical downscaling of GCM outputs, which many of our faculty and students use. He's worked on urban flooding, planning and operations of large-scale water resource systems, and uncertainty modeling as well. He's been a reviewer for the IPCC AR5. He's been a recipient of the Alexander von Humboldt Medal of the European Geosciences Union and a distinguished visiting fellow of the Royal Academy of Engineering in the UK. He's a member of several editorial boards of journals, and he's designed and taught a very large number of courses, both in water resources and hydrology, as well as in climate change related areas. He's also currently a J.C. Bose National Fellow and a Fellow of the Indian National Academy of Engineering, the Indian Academy of Sciences, and the Indian National Science Academy. Over to you, Professor Majumdar.
Thank you very much, Professor Parthasarathy. Can you confirm that you can hear me clearly?
Absolutely, very clear.
Yeah. Okay, thank you. It's a privilege for me to make this brief intervention on this, and I particularly thank the Dean and R&D, Professor Atrey, for making this happen. So in this talk, I'll come to specifics after those wonderful broad level talks which set the setting for this workshop. I will talk mostly on specifics on how the current knowledge and the technologies that exist can be used to understand as well as handle the risk. So as a brief setting now, you can just look at what has been happening in the country over the last few years. The Chennai floods, which caused 400 deaths, and the rainfall there was almost a 100-year rainfall event. Whether this happens once in 100 years or this frequency keeps changing, that becomes an important question. But exactly at the time when the city was flooded, there were also extremely high releases from two upstream reservoirs that aggravated the floods. Similarly, Kerala floods of 2018, they caused more than 400 deaths and an enormous damage to property. Again, here the rainfall was 42% higher than the normal rainfall, and the total economic loss was about rupees 31,000 crores. Then we had this year, again, devastating floods, very tragic, because people were trapped in these kinds of tunnels where the hydropower project was going on. It disrupted 4 hydropower projects. The reasons for the causes for these floods are being still investigated, but there is a suggestion that a huge hanging glacier, 15 football fields long and 5 across, they had separated from the mountain and plummeted into the river there. So these are very tragic events, and we need to understand how we can use the current available knowledge as well as technologies. So the IPCC report that has been discussed earlier, has been referenced earlier, which has been released just recently. This shows that the heavy precipitation events in these regions, and we are located here in the South Asian region, have been increasing. But whether they are because of the human contribution, that confidence is a bit low in our region. So similarly, the same IPCC report also shows that as the temperatures increase, maybe start going around 1.5 degrees, etc., what used to happen once in about 10 years, this is a 10-year event, may start happening 1.5 times, similarly 1.7 times as you progress and so on. Now, these have very significant implications on the flooding. So when we are looking at the flooding events, you need to understand also that it is caused not only by the high intensity rainfall, but also how the ground responds. So we need to look at whether the high intensity precipitation is increasing across different regions, and how does it convert itself into changing flood risk on the ground. And what happens to the flood resistant cities, whether we can build those low impact development and so on. And with the current knowledge available on the numerical weather prediction models, on developing the numerical weather prediction models, can we combine it the hydrologic models to obtain the forecasts as well as the long-term responses and so on. So I'll first touch upon some urban floods issues. Again, as I said, this is a more specific study where I'll show what are all the possibilities with the current available knowledge as well as with the science. So as you can see, the two catchments here, the same precipitation happening on this pristine type of catchment will produce a much smoother runoff, and therefore, as far as the floodings are concerned, the urban areas like this, when we're talking about the urban floods, any rain that falls immediately gets converted itself into runoff, and therefore the peak is very high, as well as the time to peak is very, very small compared to these kind of catchments. And this poses an enormous challenge to understanding as well as handling the urban floods. Now, when we are understanding the urban floods, you need to look at what is happening to the atmosphere in terms of the high intensity rainfall, as well as how the ground responds in terms of the hydrologic response of the catchment itself. So one reason for the increased rainfall in the urban areas has been the urban heat island effect because of the materials of construction that we use, lack of vegetation, waste energy, air pollution, tall buildings, and so on. We have created a heat island here, because of which the rainfall intensity is increased tremendously, almost up to 120% and so on. So we looked at what is happening in Bangalore city over the last so many years. From 1901 to 2011, we had data from IMD. The average temperatures, daily temperatures, are continuously known to be increasing over the last so many years, about 60 years. Then we look also at the increasing precipitation itself. Now, as you can see, the lower duration, we are looking at high intensity, short duration precipitation, because these are the kinds of intensities that are important in the urban areas. So as you can see, the nearer past has much, much higher intensities compared to the farther past for a given frequency. This is 10-year return period. Once in about 10 years, these kind of intensities of rainfall can be expected. And I'm talking about the Bangalore city here. There is almost a 100% increase with respect to the past. But as you progress in time, maybe 24 hours, etc., there is not too much of a difference. When we go to the discussion sessions, I'll clarify all of these points. But it is important to realize that the floods that are caused by high intensity, short duration rainfalls, they are increasing tremendously. Now, this is what has happened in the past. But can we see what is likely to happen in the future? This idea of relationship is just what I showed. For a given frequency, for a given duration, how the intensity is likely to change. Now, because of the constraints that we have on the climate models, we need to fall recourse to both dynamical as well as statistical downscaling and bring it down to urban scales. And I'm talking about Japanese models here. This is a Japan Meteorological Association. From global scales, they bring it down to regional scales. Now there is a mechanism by which you can combine the numerical weather prediction models and do a dynamic downscaling at very high resolutions. In fact, the Japanese models bring it almost to the block levels here. Now this is what we do, but when we are using this kind of knowledge, you must also understand that the climate models are deterministic models, and therefore we must necessarily address the uncertainties associated with this when we are looking at developing adaptive responses. And this is what we do. We take a large number of models, large number of scenarios, and then reconstruct how the precipitation is likely to change. For example, you look at this point, this is, I'm talking about the future. This is a representative concentration pathway and the most critical one, and we are using the previous one, the previous scenarios. That is AR5 scenarios. As you can see again, this kind of durations which cause flooding in the urban areas, they are likely to increase tremendously. In Bangalore city, they are increasing about 100 by about 100%. And that is what causes problems in developing adaptive responses, as well as building structural as well as non-structural measures for the urban areas. Then we bring it down to the ground. As the precipitation happens, the ground responds in a particular way. If you have high resolution data on how the buildings are located, where are the parking lots, where are the gardens, etc., very high resolution data, Then we develop a very high resolution terrain and land use map. We use the shallow water equations to see how this particular watershed or landscape responds to high precipitation, and then develop various scenarios. For example, we may have digital elevation models like this. We may have the land use land cover patterns. We also have the complete data on stormwater drains, lakes, and so on. So we integrate all of these into the hydrologic models. So this is a map that we generate out of global data sets from here, a very high resolution map along with the LIDAR maps. And then we also set up water level sensors at various locations in the city. We have set up about 28 such water level sensors. These will give on real time the water level as it rises. And similarly, we also have the LIDAR data. This is light detection and ranging. As you can see, this is a very high resolution type of technology, terrain technology. You can almost distinguish between the leaves here on these. So this kind of a resolution is necessary for urban areas. And using all of these, we also look at what happens to the lake depletion kind of problems, where the lakes are being encroached upon for development and so on. As you can see, as the depletion happens, what used to cause, at this scale, it may be difficult for you to visualize, but what used to create about 2.5 meters of flooding can go up to 4.2 meters of flooding. Similarly, we look at low impact development. For example, infiltration trench, rain gardens, etc. Wherever there is a space, we look at those kind of possibilities and show that about 30% of reduction in the areal extent of flooding can be achieved through this. So on the urban floods, there are
We are not able to hear.
to hear. Am I audible now?
Yes, now we are audible.
Okay, I hope I did not lose my voice. All right, last
few
part.
Seconds.
This is on the riverine floods. As you look at the river scales, the problems are much different. And I'm showing this Uttarakhand floods, which have been happening over and over again in the Alaknanda as well as in the Bhagirathi river. So you look at Rudraprayag, which is located here, as well as Joshimath. And the first slide that I showed on Uttarakhand floods had these two places. Now, after 1995, the discharges, I'm now talking about the river discharges. River discharges have tremendously increased. And this is a very high magnitude of increase because we are talking about meter cube per second from 2000 to 3000 approximately. So these are the kinds of intensities that we need to start looking at. However, when we are talking about river floods, we must understand also that the river floods are not just caused by rainfall. There are several other factors that contribute, and therefore we may start looking at sea level rise along with the increase in rainfall. Similarly, storm surge along with the increase in rainfall. You just look at these curves here. This is if you look at only rainfall, these are the kinds of risks or probabilities that you would have got.
We're unable to hear you again.
Yes. Professor Mujumdar, we've lost your audio again.
Continuously.
Okay.
So we need to look at both these aspects, that is rainfall as well as the other affecting factors. Then there is another aspect, especially in the Himalayan floods. What is also important is that there is an incessant continuous rainfall, very high rainfall incessantly occurring day after day after day. And therefore, we don't look at only one event of rainfall, but we look at the consecutive days of rainfall, which will cause tremendous intensities as well as the magnitudes of the floods. So we look at, for example, Uttarakhand floods again. Uttarakhand, you look at what was happening before 1980 and after 1980 in terms of the consecutive high intensity rainfall of 4 days duration. So an increase is observed in the nearer past compared to the farther past, which means that the probabilities of concurrent occurrence or consecutive occurrence of these rainfall is increasing continuously. Then we ask the question, what is happening to the return period itself, concept of return period under non-stationarity. Non-stationarity, I mean, the history is no longer providing us a clue to the future, and we need to start looking at the future in a non-stationary way. So the infrastructure that we would have designed based on what has happened in the past will be valid only up to certain point in future, for example, 2027. And this is a work of Professor Arpita Mandal of IDP there in Mumbai. So what it says is that whatever infrastructure you designed based on the historical data is valid only at up to certain point. After that, we need to start revising the infrastructure. Then we look at how we operate these reservoirs themselves. For example, the Hirakud reservoir, when the flood discharges are known to be increasing, can we provide adaptive rule curves, how to operate between the flood period in the flood period of July to October. And this is what we do through several iterations and so on. The last part that I would like to show is, again, we come to the Upper Ganga Basin and show how these floods can be reconstructed with the modeling technologies that are available, so that even in the absence of ground level data, we should be able to reconstruct. Here we combine the WRF model, this is a numerical weather prediction model, with the hydrologic model to show whether we can reconstruct these floods so that the knowledge on those floods can be improved. The last slide, I would like to show with all of this knowledge, what can we do? For example, this shows for the Kerala floods, we put the boundary conditions here. This is because of the tidal rise, etc. We create artificial boundary conditions and put a very high intensity rainfall that actually happened, and put high resolution data and show how quickly and how far, aerial extent wise the floods increase. So this is what I just wanted to tell you, that the current knowledge of technology as well as science, hydrologic science, must be used to develop adaptive responses to what is happening on the floods in the ground. So thank you very much for your attention. I would be happy to contribute in the discussion sessions. And if there was a break in my voice, I apologize. There is a slight break in the internet today for this. Thank you very much.
Thank you.
Thank you very much, Professor Mujumdar. Several important points you outlined, especially in terms of the methodology, the strategies that we need to follow in order to better understand risks and also to generate future risk scenarios, and then use that for better adaptation and for flood reduction measures. And I think one of the important points that you made was also about how river floods are compounded by sea level rise, fluvial flooding and storm surge. So we should look beyond rainfall, even though that's a very important contributor. So all the different factors that can contribute to intensity and magnitude of floods, it's very important to understand that. And especially of relevance to this workshop, I think your point about non-stationarity and not depending on historical data, especially for building infrastructure, developing standards for infrastructure, is something that's of value to us in this workshop. Thank you very much. So we are running a little bit over the time, but I think that's okay. We've had a very good base foundation set for us by the three speakers, which will enable us to discuss these issues in the three breakout sessions focused on sea level rise, coastal flooding, and also the cooling, residential and workplace cooling. We'll just spend a few minutes on a few questions, and then we can break for 5 minutes or so before we go to the breakout sessions. So I'd like to start with one question that came from one of the participants. I'll just pose these questions, and any one of you can choose to respond. So first question is primarily about standards. So the question is, how can dynamic standards cope with the fact that scenarios are always changing? So when there are changing scenarios, how can dynamic standards be of value for us?
Would you like me to pick up
Yeah.
on that?
Yeah. Then there's a specific question to Yajima-san. Can we replace existing refrigerant from the air conditioner and replace the same by R32, or do we have to do some changes in the design? So maybe John, you can take up the first question, and then Yajima-san can take up the second question.
Well, thank you. Yes, how can standards and be dynamic and pick up the future? Well, the British standard 8631 about adaptation pathways is designed to do just that, because one of the things that we are faced with is a choice. And I think the choice is designing something now that might last for infrastructure, for example, long life infrastructure that might last 50, 100, 200 years. We could design something now to cater for the future climate and build in the uncertainty and end up with something that is well over engineered for a future that may or may not happen. And that's one thing that's been happening in some cases. I know of one railway project in the UK that's been designed to withstand the 1 in 1,000 year flood, which is a decision that was taken. And by 2100, the 1,000 year flood might be 150 year flood. And that's just one example. But the adaptation pathways approach asks you to look at different scenarios in the future and select an option that can be constructed. And the sort of philosophy behind this approach is that you can build something now and build in passive provision for a different future. So one example there could be a tall building where the wind speeds in the long-term future are not understood, but we can build that building in such a way that we can retrofit it in 30, 50, 100 years' time, because we've made passive provision. Another example is flood levees or coastal defences. If the sea level is going to rise 1 metre, 2 metre, 3 metres over the next couple of centuries, we can make the foundation strong enough and just build that wall to cater for sea level rise this century, and then build on top of it in time. So I think the adaptation pathways approach is a useful approach to deal with these long-term uncertainties. Otherwise, we have to build in that uncertainty now for the full life of the asset, which I think is a rather costly way of doing things. I hope that helps to answer that question. It's a good point.
Yes. Yeah, thank you very much. I think the last point about adaptation pathways approach is something that some of us are also trying to include in our syllabi and use in our projects. And we would like to maybe discuss this with you more offline. Yajima-san, would you like to respond to the question?
Okay. The question is design change for R32 alternative. That's right? Design change?
Yeah, the question is about the question is, can we replace existing refrigerant from the air conditioner and replace the same by R32, or do we have to do some changes in the design?
Okay. Conventional refrigerant is R12, R22 or R14A, and from as you know well, R14A, half of R14A is R32, and it is very easy from just change from R14A to R32, and R22 to R32, some change is needed. Compressor size or heat exchanger pro circuit number, and so on, and refrigerating oil. That in many countries, R22 can be changed, alternated to R32. And if you want to the refrigerant or R22 and existing unit, some difficult to change R12 to R32. Capacity difference or oil problem in case of new products, the change of refrigerant is relatively easy. That's okay.
Yeah.
For your question.
Thank you so much.
Thank you.
Yeah, that's a very specific response to the question that has been posed. There's a question for Professor Majumdar, which Professor he has answered in the chat. So Professor Atrey has asked about error percentages in the model predictions, and Professor Majumdar has replied saying that the errors and uncertainties vary from urban to river basin scale. If you'd like to expand, you can do that. I just wanted to add one more question. So we know, and you've mentioned it in your talk as well, about uncertainties, and we also have problems related to attributions of events to climate change. So as somebody who works on climate policy, one of the problems we often come across is that policymakers, government officials, they always say in the presence of these kinds of uncertainties and attributions, it's very difficult for us to develop adaptation strategies or adaptation pathways. So if you'd like to just briefly comment on that as well.
Yeah. Thank you, Professor Parthasarathy. I hope you can hear me, because there is some problem in the internet. Yeah, first I'll address Professor Atrey's question. And thank you very much, Professor Atrey, for the question. There are two aspects here. One is errors as well as the uncertainties. And both these vary from urban scales to river basin scales tremendously, very significantly. Because especially when we are talking about forecasts, the forecasts at the urban scales are much different. I mean, the way we develop the forecasts are much different compared to what we use at the river basin scales. So to be very specific in response to your question, on the urban scales, typically if we use IMD type of forecasts, which are developed on a larger scale, but we use it at urban scales. Now, these forecasts are quite poor when we want to do actions on the ground immediately. For example, next 6 hours, what is likely to happen, etc. These are quite poor as of now. However, we use the STAC Ahmedabad forecast, that is a Space Application Center forecast, which runs a high-resolution weather research forecast model at the country scale, but they provide for Bangalore city specially. Now, these forecasts are much better, and they provide for every 12 hours, which can be updated every 6 hours and so on. So these forecasts have a very high reliability. Our only problem is the spatial distribution is not captured correctly. And when we come to the river basin scales, the times of forecast will be of the order of 12 hours, 24 hours, and so on. So because of this smoothing, at those levels, the forecasts are much better compared to what happens in the urban scales. I would like to also quickly answer the uncertainty aspect of Professor Parthasarathy. This has been one of the questions that has been bugging all the hydrology community, and indeed any impact development community, that we are unable to say for sure that this is likely to happen. For example, I showed the increase in the rainfall intensities, which convert themselves into hydrologic designs. For example, when you are doing any design for the flood control, you need to have a particular intensity of rainfall and the associated discharge. And we are still providing the bands of uncertainty. So the current research and current thinking in the hydrology community is to reduce the uncertainty so that these kinds of outputs would be actually useful for policymakers. In countries like Canada and some other countries, what they have done is for urban hydrology, they are actually prescribing that 30% of allowance you need to make in any of your designs and so on. I'll be happy to contribute in the discussion because I don't want to take too much time here.
Thank you, Professor Bujumdar. I hope that all the panel, the plenary speakers will also join us in the breakout sessions where we have allocated more time for discussion and question answers. And of course, we'll come back to the main session and have a discussion also. We had allocated more time to the final summarizing session, but I think there'll be the actual summarizing and comments may not take so much time, so we will have a little bit more discussion at that time. So please do stay with us. So I'd like to now request Devasmita to briefly explain the procedure for all of us going into the parallel breakout sessions and then coming back. So it's 3:30 now. So we'll have a short gap. I think we can start at 3:40, right, Professor? That is Indian time, Professor Atrey?
Yeah, that's correct.
Yeah, 3:40 we'll start. So just 2 minutes if Devasmita can explain. So we have allocated 1 hour and 5 minutes for the breakout sessions, 15 minutes for 3 speakers in each session, and then about 20 minutes for the question answer session. There's a moderator allocated to each of you. Please do know that the moderators also have your PPTs. In case you run into any difficulties, please let them know. They can play the PPTs from their side. And all of them are from IIT Bombay, so they know the system fairly well. So let me now hand you over to Devasmita.
Yes, sir. So now we will be entering into the second segment of our workshop. That is the breakout sessions. So we are having 3 parallel sessions. Session A, residential and workplace cooling. Session B, urban and coastal flooding. Session C, sea level rise in coastal zone. So quick instructions for our participants, especially. So number 1 would be each participants should join the session they have registered by clicking join. You will get a notification on the top right hand side of the participant panel as soon as the breakout starts. And number 2, as you all have aware that you have received a Google Sheet, and you can post your question on that said Google Sheet. And please do not post any questions in the chat box. Number 3 would be if any participants entering into the wrong breakout session, you can write a message in the chat box to host asking to permit in the preferred session. And you are strictly not allowed to switch into any breakout session in between. So these are the brief instructions for our participants, and we shall start by 3:40 as Professor Parthasarathy said. So let's wait for 2 minutes.
Join breakout. They have to click on breakout sessions, is it, at the bottom of the screen?
No, sir. The moment I will start the breakout session, they will receive a notification in the right hand side corner, participant panel. They will get choice to join their respective sessions.
All right.
So join option will be there. So you have to click the join and you have to enter the breakout sessions.
Yeah. And at the
The
end, they will
sessions which
receive
you
another
have
message
registered.
again, right?
Sorry, sir.
At the end, they will receive another message to go back to the main session, right?
Right, sir.
It'll
Yes.
automatically. All right.
Yes.
All right then. Yeah.
The
Thank you so much.
the moment all the breakout session ends, so our co-host will be giving a signal that we have ended all the breakout sessions, and I will be ending all the breakout sessions then, and automatically all of us will be in the main session.
All right. Thank you so much. Professor Atrey, do you have anything to say, or shall we just close for 5-6 minutes?
We'll go ahead now. We'll go ahead. Yeah.
Yeah, we'll go ahead. So we have a short break, 5 minutes, what we call as bio break here in IIT. And then please come back, join in 5 minutes. You don't have to leave the meeting. You can just switch off your video and then come back in 5 minutes and join the breakout sessions. Thank you so much.
I would like to request to all our co-hosts, please put the Google Sheet link in the chat box when the breakout starts. Thank you.
So, Ms. Devasmita, which session we join, the speakers?
Sir, I have assigned all the speakers and moderators. As per your preference, I have assigned you in session 2.
Okay, thank you.
Flooding.
Is that perfect, sir? Or you
Yes,
would like to
you.
join another session?
No, this is perfect. Thank you so much.
Okay, thank you, sir. And Professor John Dora, would you like to join in session 3? Can you hear me, Professor?
Yeah, please, that'd be fine. I might have to disappear though, because I've got a couple of things to do. Thank you.
Thank you. Okay, all right, thank you.
Good afternoon, Devasmita. Is my voice clear to you?
Yes, sir.
I am in this.
Yeah, it is very much clear.
Yeah, I am in this session C, which is sea level rise.
Right, sir. Yes.
Yeah, okay, thank you.
Yes. Mr. Yes. Mr. Deshpande, we can hear you.
Sir, namaskar. I was just wondering that I don't have the sharing button on from my side. So is my presentation received from the moderator side?
Yes, sir.
Yeah, it has been received, sir. No problem. But when the time comes before your presentation, you will be given the shared rights.
Okay,
So that time you will be able to share.
Thank you.
Yeah, this is Professor Manas here, who will be moderating the session.
Namaskar, sir. Namaskar. Thank you.
Namaskar, sir. Namaskar.